Okay, so let's go back to those notes from yesterday. Here we are. Okay, so in order to have one solution, all you need is one thing. Okay, so eyes up here. You really got to understand these concepts so that the today's Delta Math is really easy. And I did have first period, probably like half the class finished, like some of you finished in like 10 minutes. So to have one solution, all you need is for the variable parts to be equal. Not equal. They have to be not equal. I know this one says negative 4x and that's positive 4x, but those are still different. So in order to have one solution, the x values have to be different. That's all. The constants here, they could be the same or different. That doesn't matter. But you need to have the variables to be different. So if you have negative 4x, you could have positive 4x. You could have 8x. You could have just x by itself. You could have 1/3 x. It doesn't matter as long as they're different. If you have different variables on both sides, you're going to get one solution. And the constant parts, it's not going to matter. Any questions on that? Now let's move on to no solutions and infinite solutions. Let's focus on the variables. Here we have 3n, there we have 3n. That's for no solutions. Here we have negative 2y, here we have negative 2y. So if you have the same variable amounts on both sides, we're either going to have no solution or infinite solutions. So what does that tell us? If we have variables, the same variables on both sides of the equation, what are our two possibilities? Infinite solutions or no solutions. The part that's going to make them different are the constants. For no solution, what can we say about the constants? Are they the same or different? Different. So if you have the same variables on both sides and different constants, no solutions. How about if you have the same variables on both sides and the same constants? You're going to have infinite solutions. Okay, so we're going to take advantage of that right now. We're not going to write the notes. What we're going to do is we're going to do 6 examples together on Delta Math. And we're going to have a variable h that we can assign any number we want to it in order to make it one solution, no solutions, or infinite solutions. Okay? So what I need you to do right now is go to your Chromebook and take it out, and we're going to I want to pause this. Okay, so let's take a look at this first example. Everyone's here. We're going to complete the sentence based on the equation shown below. And this is our equation, 8x minus 4 equals hx minus 4. So in this equation will have infinitely many solutions. When h equals, we have to figure out what number to replace h with, so we would have infinite solutions. Okay? Why don't we take a peek? Let's go to infinite solutions. Let's go back to what it should look like. So for the variable parts, the variable amounts, do we want them the same or different?
Same.
For the constants, do we want them the same or different? I'm not seeing that though. Yeah, same for the variables, same for the constants. Yeah, for infinite solutions, that's what we want. For no solutions, we do want the constants to be different. So let's take that back to our example here. So we want the variables to be the same and the constants to be the same. So what number should I replace h with? Take a look. I could replace h with any number, but what number is going to give us 8? We want 8 here. Because I'm reading this, you get infinitely many solutions when we have blank number of x's on either side of the equation. So do we want the same number of x's? Yes, not different. Different would only apply for one solution. And then there's another part. And this says the same constants, different constants. Constants can be the same or different. What do we want?
Constant can be the same or different. No, the same constant.
We want the same constant. It has to be the same. Because what's going to happen is we'll have 8x here. We'll have 8x there, which means they're going to go away, and we're going to have -4 equals -4, which is a true statement, which tells us there's infinite solutions. So let's test it out. This is what we want to answer when we have infinite solutions. Okay, that looks good. We got it. Let's try another level 1 for a different type of outcome. Okay, so this time it says, complete the sentence based on the equation shown below. So we have this. Again, we're going to replace h. This time we want one solution. One solution. So let's go back and take a look what one solution looks like from yesterday. Here's one solution on the first column. What do we want the variables to be? Same or different? Different. It could be any type of different. Here I had opposite different, but that's still different. But this could have been 8x, 9x, 1/3 x. Okay, so let's go back to our example. So what number can we not have for h? -1/2. You can't have -1/2 because then they would be the same. So do me a favor, everyone, pick a different number besides -1/2 and pick a different one from your table partner. We're all going to pick different numbers. So I'm going to pick 1/8, 1/8. Do not pick 1/8. Pick something different, and also don't pick -1/2. Pick a different number. Whatever you want. Any number you want besides 1/8 because I picked it, and -1/2 because then you wouldn't have one solution. Okay, we all pick something. Then, because you get one solution when you have the same or different numbers of x's on either side. They have to be different. For one solution, they have to be different, and the constants can be same or different. Yeah, it doesn't matter. They could be the same, they could be different. This is the only one that can have the same or different. Only one solution can have the same or different. Okay, so everybody picked a different number. Let's try it out. Yes.
Oh, I got it right.
Shh. All right. Now, this is another one. This time we want 0 or no solutions. So let's go to our example from yesterday. No solution was right here. So the variable amounts on each side are the same. What can we say about the constants? Different. So the variable amounts have to be the same. The constants have to be different. So as long as it's not 7, because that's the part we're replacing this time, the constant. We can't put -7. So I'm going to put 23.8. How's that? Pick whatever you want that's not -7 or -7. And then try to answer the bottom part. Let's see. When you get 0 solutions, when you have the same number of x's, and how about the constants? The constants have to be different, right? That's the requirement for no solutions or 0 solutions. Okay? Any questions on that? Because this is what the assignment's going to be.
Okay.
Let's move on to level 2 questions. You guys ready? Shall we move on to level 2? Yes?
Yes.
Let's do it. So this time we just have to think a little bit ahead and realize what we get when we distribute. Because h is going to be distributed into -4 plus 4. Okay? So this time we want infinitely many solutions. So let's think for a minute. To have infinitely many solutions, the number of the variables, does it have to be the same or different? The same.
Yes.
So basically, I want -8x. What number should I distribute to get -8x?
Wait.
It's gonna h is gonna get multiplied into -4. I want 2. Because if it's 2, I get -8x plus 8. And that's exactly what I want. Same variables, same constants. So what are we all gonna pick for h? Dos. Because you get infinitely many solutions when you have the same or different. Same number of x's on either side. And how about the constants? The same or different? The same. So you got to think a little bit ahead in level 2. That's all. What do I get after I distribute? Let's try it out. Okay. Any questions? Moving on to level 2 question for one solution. This time we want one solution. Let's review again what we want to see for one solution, guys. One solution. This is my one solution. What do my variables have to be? The same or different? Different. Okay. And the constants, it doesn't matter. They could be the same or different. So let's make that happen over here. So we have to distribute. What number can I pick? Anything except -7. So pick any number you want. In fact, let's all pick a different number again. Pick a different number. And pick a different number for, well, that's it. Pick anything except -7. I'll do 2/5. And then answer the questions here. So let me see. The x's have to be different. It has to be a number.
Yeah. Wait, what is this like a number?
Good try, though. I like that thinking. Yeah, it wouldn't accept a letter.
Why?
Okay, how about the constants? Same, different, or it doesn't matter?
Doesn't matter.
Does not matter. Okay. This is why we have more situations where we get solutions and we don't get solutions.
I get it.
All right. Last one. What do we want to get this time, guys?
0 solution.
0 solutions. So remember, for 0 solutions,
We have to have
what do we have to have for the variables? Same or different? Same. What do we have to have for the constants? Different. We want the same variable amounts. We want different constant amounts. Okay, so what number do I have to distribute? Well, here if I distribute, I get 14x. So what do I need to make 7 so I get 14x also? 7.
You said 7.
Let's do it. 14 here, 7 there, because then I'd have 14x again. 7 here, and then How about our number of x's? The same or different? Same. And then the constants have to be
Different.
different. There you go. Okay, so now, the rest of these you have 12 to do level ones, like the first three we did, and you have to do 8 level twos, the last three we did. Okay? So this is the assignment for us. Hopefully you can finish it in class because that means no homework, or you can catch up on other work. Okay? All right. So we're done.